In this video, we're going to be talking about analog to digital converters. In electronics, we have to convert analog to digital signals all the time because it can be super convenient. Before we continue, I have to tell you what a signal is very shortly. A signal is something that looks like a wiggly line, for example, something like this, or it can be also something like this, or it can have many other forms that carry some type of information. In ADCs, or analog to digital converters, that information is almost always a voltage, and today it's gonna be a voltage too. If we're talking about an analog signal, we're talking about a signal that looks like a continuous line, so something like this. Okay, and as you can see, it has infinite values. For example, let's say this is 1 volt, let's say this is 2 volts. So as you can see, it can be 1 volt, or it can be 1.01, or it can be 1.5, or it can be anything in between. Whereas by a digital signal, I mean a signal that looks something like this. For example, and it has finite number of values. For example, it can have 2 possible values, or 4 or 8 possible values. So digital signals always have 2 to the power of 1, or 2 to the power of 2, or 2 to the power of n values. But they can't have, for example, 3 possible values, and the reason for that is very interesting. We've all heard before that computers think in binary, but what does that exactly mean? First, computers fundamentally use transistors to work, and transistors, simply said, behave like a switch. They have 2 possible states. They are either on or they are off. In bits, we usually represent the state on as 1 and off as 0. So now let's say we have a digital signal that can have 4 possible values: 0 volts, 1 volt, 2 volts, or 3 volts. If we say to the computer 2 volts, it doesn't mean anything intuitive to it, like it does to us people. But if you say 1 0 to it, which is 2 in binary, it will mean turn the first transistor on and the second off. And that is much more intuitive to a computer. And notice that for us to use those 4 values, we had to use 2 bits. So 0 0, which is 0, 0 1, which is 1, 1 0, which is 2, 1 1, which is 3. And an easy way to check how many values you can have at a digital signal with a certain number of bits, you can use this formula: 2 to the number of bits equals the number of values. We can have in a digital signal. For example, now we use 2 bits, so we substitute 2 to the number of 2 equals 4 possible values, which is exactly the case from above when we had 2 bits to represent 4 possible values. Now, this is one of the reasons we have to convert from analog to digital signals, but another big one is the fact that it's much easier to get the right signal when there is noise. Suppose we had some signal that has some noise in it. Suppose we had some signal that has some noise in it, and it looks like this. Suppose we had some signal that has some noise in it and it looks like this. So it has some noise over here, then it has over here. Okay, now let's say our digital signal can just have two values, 0 and 1. It's very easy to tell from this noisy signal what the original signal is. If we take this part, for example, you can easily see that it's a high signal and we give it a value of 1 in our digital signal. The other one, this one right here, you can easily see that it's a low signal, so we assign it a value of 0, and so on. So this is for today. Hope you enjoyed it, and see you in the next video.